Hello everyone, I am Akshatulal, a PhD student at Vanderbilt University, and today I will be presenting on the work an iterative participatory design approach to develop collaborative augmented reality activities for older adults. In 2018, there were around 28,000 long-term care facilities in the US with a population of around 5.7 million older adult residents, and this is shown to be increasing rapidly. The problem with older adults at LTCs is that they are more likely to experience loneliness due to the less frequent contact with their friends and families. This has also been exacerbated and made worse by the COVID pandemic, which has prevented older adults from being visited by their friends and families. Let's understand what has shown to actually mitigate loneliness. Firstly, the improvement in the quality of relationship and also social connectedness with friends and family. In non-long-term care facilities, social connectedness is often developed through physical face-to-face interactions and joint activities with one's friends and families. Many a time in LTC communities, this option may not be available, and older adults have to rely on remote communication technologies such as FaceTime and Zoom, which have demonstrated mixed results in their effectiveness. The most commonly used interactive communicative technologies for today for older adults in keeping in contact with their friends and family are Zoom, FaceTime, and also sometimes even through video conferencing. However, these have a certain disadvantages. Firstly, they have atypical eye gaze, and also looking at the mirror image of oneself all day is not quite typical in in-person interactions. And finally, there's a lack of mobility. Hence, research has shown that people still prefer in-person interactions, and there is something unique in in-person interactions that are not able to be recreated in 2D communication technologies. Our goal is to use augmented reality to enable 3D telepresence, that is the ability to simulate in-person interactions using augmented reality. As can be shown in the image, there are two users in their two remote local environments, and they can view each other through their the photorealistic avatars. And one can also have their gestures mapped to the avatars, which is able to convey the non-verbal behavior of the interactions. Before using augmented reality as a medium of communication for older adults at long-term care facilities, we need to understand firstly how do older adults actually view this kind of technology at long-term care facilities, and also what are the types of activities that they actually want to do with their friends and families using this technology. This leads us to our first research question. What are the types of collaborative AR activities that older adults would actually like to do using this technology, and what types of activities that would help them develop the social connection that could mitigate loneliness. And secondly, we also are interested in the challenges of implementing such an activity in long-term care facility. This includes all the ancillary challenges of the infrastructure requirements, and also how this type of technology can be adapted to older adults' needs. In order to identify the challenges and the issues associated with implementing such an activity at long-term care facility, we decided to use an iterative participatory design involving stakeholders, that is the older adults themselves, their friends and family members, and also the long-term care facility staff. This method was primarily used because not all issues are known beforehand, and gradually through the iterative nature of this study, we can actually discover what are the issues that can actually come up, and also get solutions from the stakeholders themselves on what would be a useful approach to solve these problems. This study was conducted at a long-term care facility in Tennessee in the USA. And recruitment was primarily done to the long-term care facility staff by the use of flyers and also word of mouth. So in total, there were 8 older adults who participated, 5 long-term care facility staff, and 2 family members. And the breakdown of the age and gender of older adults is shown. And also, in order to test the cognitive capabilities of older adults, we used the SAGE test score. Any score that is below 17 is considered people with having a little bit of thinking and cognitive problems. And all of the participants in our study belong to this category. Now, there are different devices that can be used in augmented reality. In our case, we use the HoloLens 2, and it has pretty standard methods, interaction methods in augmented reality. So there are two types of interaction, primarily near interaction and far interaction. So near interaction is when you can actually uh, touch on the virtual elements in the HoloLens, as can be shown here, a tap interaction where the user uses the index finger to touch on the menu buttons. Another form of near interaction is the pinch interaction, where the user has to actually physically reach onto the object and then use the pinch gesture to move it around. These are standard interaction methods in HoloLens, and we began our study with showing the older adults using this standard interaction. When using far interaction, that is basically to move objects that are further away from you, there are three steps. First step is you point at the object and a dotted line appears, as can be shown in the image. And then you again make the pinch interaction and the dotted line becomes solid, showing that the object has been picked, and one can move their hands around in order to move their objects. And this is the type of interaction that is generally used for moving items around when one is seated and cannot move around the environment. And this was the starting point again that was shown for older adults when interacting in augmented reality. The main findings included 5 main topics. First one is the older adults' perceptions of the avatar. Initially, we used the in3D volumetric scanning application, and then we switched to Unreal's MetaHuman, which was preferred by the older adults. In terms of the activity they liked many of them, including checkers, bingo, cards, fireplace decoration. We decided to prototype 2 of these, that is checkers for simulating near interaction and fireplace for simulating far interaction. For the 2 types of interaction modalities, for near interaction, older adults found it difficult to perform the pinch gesture, which had to be modified due to their dexterity issues caused due to arthritis. And for far interaction, they wanted their voice also incorporated, so voice commands can be used to actually move the objects, which made it much easier. In terms of the user interface, the older adults preferred highlighting of a checkers piece whenever it is picked up, or a fireplace object whenever it is picked up, for easier usability. They also liked clean menus without nesting, and also the ability to scale menus so that they can read the objects much more clearly. For remembrance of interactions, every visit we had to again remind them how to actually interact since the visits were one month placed apart. But each time they could learn faster, and they remembered elements of the previous interaction, which elements were harder, which were easier, and they could learn the way to interact a bit faster. Finally, when considering all these findings, we can make certain conclusions and the recommendations that need to be followed when implementing collaborative AR activities for older adults. Firstly, it's important to cater to a diverse set of older adult populations. So it's important to keep multiple options available. For example, if some people are comfortable using voice interactions, they should be able to do, but it should also be the hand interaction capabilities should also be kept as an option that is available for more functional older adults. Also, many things such as the dexterity level when interacting with a collaborative augmented reality need to be taken into account. Also, the literacy levels of the participants. It might also so happen that this study was conducted in the United States, which is a developed country, but in developing countries it might also be people might not be so literate and exposed to modern technologies. Also, the physical and cognitive capabilities of the participants need to be taken into account, especially when designing activities, whether they can actually walk or move forward to actually pick up an object, and also their cognitive capabilities in terms of understanding the instructions and in order to actually interact with AR. These things need to be kept in mind. Another very important thing is that it is important to understand that collaborative AR is a new kind of technology, and interacting in using their hands naturalistically is not something that you do on a daily basis, and hence it's important to deal with frustrations when older adults feel there might be a learning curve in the initial 1 to 2 visits of how to interact with collaborative AR. So it's important to deal with frustration, and it's important to let the older adults know that when conducting such studies, that it's not their fault that they're not able to do, but it's the onus is on the user-centric design of the technology to make it much easier for them to actually interact in augmented reality. Now, one thing to understand is it is important to balance functionality and simplicity when designing older AR activities for older adults. By this I mean that it's better to not make something overly fancy, but just keep it simple and just keep it to the bare functionality so that it's easier for a wide range of older adults to actually understand and use this technology. One thing to consider is the infrastructure requirement, especially with this telepresence technology. It's important that the long-term care facility has good internet speed. Considerably 50 Mbps or above would be at least required, and also the desktop or the computer that is used to run these programs would actually need to have a minimum requirement of 8 GB of RAM. This is primarily due to the game engines that are used to run these programs, primarily Unreal and Unity. In conclusion, collaborative AR has a lot of promise for older adults, and many of them were enthusiastic, and all 8 older adults had actually participated throughout the study, showing their interest. However, it has to be noted that these activities need to be adapted according to the older adults' needs for them to partake and enjoy these activities. Thank you for listening, and if there's any questions, feel free to let me know, and also refer the paper that will be put up at the conference.